From its humble beginnings on a parking lot at the University of Texas at Austin, Formula SAE has grown into the premier collegiate engineering and design competition in the world. In May 2001, celebrating its 21st anniversary, 105 teams from 7 countries met at the Pontiac Silverdome to compete and learn.
We can teach things in this competition that we simply can't teach in class.
If you're looking for an automotive engineer, you want to be out here.
It's a total program. It gets better year after year.
Formula SAE is built around a series of 7 static and dynamic events that test the team's engineering and project management skills. The students must finance, design, construct, test, and then compete in their cars against other teams comprised of some of the finest automotive engineering students in the world.
This year we have built a monocoque structure from the main roll hoop forward. We've reduced weight this year by 10 pounds, which is a weight saving of 20% on the chassis. We've improved our torsional rigidity by about 35% to 1,250 foot-pounds per degree.
In essence, each team that comes here is a mini product development team. They've been through a year-long effort in designing, developing, building, and now evaluating a vehicle, which is essentially the business that we're in. One of the main differences is that they're doing all of that in a much shorter time frame than we typically see in our industry.
I think the monoshock had many benefits when we looked at it initially. It combines the ride characteristic of 2 shocks with a simple system replacing with one, obviously the cost and the weight savings, while at the same time we can integrate roll control without an anti-roll system. So the packaging was very nice.
They have learned how to work as a team. They've raised the money. They've fought the political battles. They've had to work together. All the intangibles that we're looking for in a young engineer that they don't get strictly from academia.
The Venturas that have been designed using computational fluid dynamics, trying to improve the downforce that we get on the vehicle, just by carefully sculpting the underside of the side pods. We've been able to get somewhere in the region of about 60 newtons downforce at about 50 miles an hour.
They, like all the other universities, are combining business with the idea of being an engineer in the field, budgets on how to build the vehicles, budgets surrounding meeting deadlines, times, building business plans. So it gives the students a chance to interact in real-world technology.
The 2001 Formula SAE would see only 3 of last year's top 10 finishers repeating in that category. The University of Texas at Arlington, a perennial contender, returned the top 10 form in 2001 after finishing what was for them a disappointing 15th in last year's competition. Joining the event's elite for the first time since 1996 was the ECOLE de TECHNOLOGIESE Supérieure, or ETS.
We figured out that we have to do some step further into increasing the cornering speeds. Just by putting the wings on the car on the same day, we were able to drop the time for the big skid pad, that's 200 feet skid pad, for a second. That means that we were able to achieve the increase in lateral forces.
Everything we have done is based on our experience or past experience that the school has acquired. The main goal was to have a theoretically perfect car. We wanted to have the best balance because we know there's compromises that are made in every aspect of building a race car.
The competitive aspect of Formula SAE is the main attraction for many of its student participants. But the engineering challenge stimulates their performance in other areas.
When they participate in this program, that they are more eager to learn the new programs and try to apply them into that they are designing and they are making it. So I can see that they are more enthusiastic to learn it and eager to get some new things than the other guys. The other guys just try to learn the course and to get the credit and get out of university. But these guys are trying to learn more on what they want to learn.
They learned how to manage a project from the beginning, and time management is extremely important. They learn the tie-in between theory that they learn in class and real life. These kids are much more attractive to potential employers because they can think on their feet, they can communicate with people, they learn to listen, they learn to express their ideas better.
We generally like to say that universities graduate students
and industry takes them for a year or two and makes engineers out of them. But kids that graduate after working on a project like this truly graduate as engineers with that experience that they would normally get in industry. So they have quite a head start.
For the past 8 years, a consortium consisting of General Motors, Daimler Chrysler, and Ford has hosted Formula SAE. Under their stewardship, the event has seen a remarkable increase in the number of schools participating and has generated sister events in England and Australia. The Big Three and others regard Formula SAE as an invaluable resource for producing the kind of focused, creative, ambitious individuals that can contribute and prosper in a competitive environment.
We have a key institution program that affiliates us with institutions, universities, and academia all over the country. Many of those institutions also participate in Formula SAE, so it provides a nice synergy between our key institution program and our engineering recruiting activity that lets us recruit folks that have motor oil in their veins or have a racing spirit.
Ford does recruit at every FSAE event, and we do give priority to students who participate in FSAE because we think it really allows the students to apply their academic skills to a real-world problem. The students have to think, design, build a race car, and then not only have it run, but have it functionally compete against other top-notch engineering schools in the country.
We've hired over 90 people from Formula SAE, graduates of Formula SAE. And again, the passion for this business, the skill sets that they have learned from competing in Formula SAE, all contribute to the success within the company. This is a great entree into all the best automotive manufacturers, and it's a link that they won't have otherwise, because we use this as an important recruiting tool.
Both the automotive industry and the support group of automotive industries have caught on to what this contest is all about, that it's producing engineers that they don't have to spend anywhere near as much time training.
We've hired some of these students. We're extremely pleased at the way they attack a job, how they actually ask for more to do.
This year what we're really trying to achieve with the engine is a very broad power range to put it in a very predictable performance range at anywhere on the track. One of the ways that we implemented that is by going with an exhaust header that was dyno tuned to exactly what we were looking for. To implement this, we run the exhaust header around. It's stainless steel. We manufacture the collectors in-house with dies that we've made.
Bosch has hired about 6 people per year the last couple of years out of Formula SAE, and typically they turn out to be excellent employees.
This year what we did on our car was a carbon fiber steering wheel with the shift buttons integrated into the steering wheel. It's 7 layers of 6K carbon fiber in the middle with 3 layers of 3K carbon fiber on the outside over sculpting foam. We also have a carbon fiber tub, which is 4 layers of Kevlar with 2 layers of carbon fiber on the outside. We wanted to increase puncture resistance in the cockpit to increase safety.
We've been involved through, as a sponsor of this event for 5 years now. We view the enthusiasm of the collegiate students here as marvelous to deal with. We see them as potential members, potential future links into the automotive industry. We've had very, very successful young student engineers come out of this program throughout all the automotive companies, as well as throughout motorsports.
In 2001, the University of Wisconsin-Madison was looking to take the top spot after finishing second at Formula SAE 2000. But Michigan Technological University was taking advantage of formula rules that allow virtually unlimited reworking of the engine in its bid to be #1. The 2 schools were among a group that had tied for 4th place in the critical design competition with 120 points each.
One of the most innovative design features in the car this year is placing the engine backwards in the chassis. And by slanting the cylinder head towards the rear of the vehicle, we were able to move the major mass members, both the engine and the driver, both rearward and downward in the chassis.
Well, we have a kind of unique feature this year with our electronic throttle. It's never been used before in a formula competition. We use it for traction control, in which we have a timing sensor on the front right wheel and also on the rear transmission output shaft. By comparing the front and rear wheel speeds, we can determine if the rear wheels are slipping.
Providing student engineers with hands-on experience is Formula SAE's main draw. But participating colleges and universities also find the visibility achieved through the event helps establish and enhance important corporate connections, while increasing their ability to recruit top-flight students into their engineering programs.
The main reason we're here is because of the relationships we want to set up with the colleges and universities that represent themselves here at SAE, to meet the advisors and to meet the students, and to see kind of students that we're going to be recruiting, because this is a terrific recruiting tool for Goodyear as well as perhaps all the other automotive companies.
This competition really offers an excellent opportunity for universities, both in the visibility and publicity that the university has, the networking that the students can have meeting with the industrial professionals here at the competition, and the engineering education that it can provide.
There are many spin-offs of these programs that can drive various research programs in vehicle dynamics, in engine design, powertrain design. There are a number of universities around here who are using these programs as springboards into something else. This is the most visible of all the SAE's activities in terms of pure publicity, pure visual excitement. These are the kinds of things that turn students on. They turn on potential donors, they turn on potential sponsors.
It's just something that the universities can't necessarily offer the student any other way. And I think for some students it can be a recruiting tool for the university to get students to come to campus because they offer something like a Formula SAE competition.
As longtime avid supporters of Formula SAE, the 2001 Ohio State team arrived at the Silverdome looking to dramatically better last year's 40th place finish.
Ohio State this year has applied a barrel-style throttle body here. Instead of the traditional butterfly valve, we have a barrel style with the hole drilled in it, and the entire barrel rotates, allowing the air to have a much smoother passage through the restrictor. And the analysis we've done on the intake is we have engineered our intake runner length and diameters to better correlate and work with the barrel-style throttle body, as is the plenum volume. And we've shaved about 2 pounds out of it this year through accurate fabrication and carbon fiber applications.
Looking to add a 6th Formula SAE championship to their resume, Cornell was the only 2001 team finishing in the top 10 with a turbocharged engine. Their goal was to build the perfect car.
You have to decide what requirements there are for a winning car in each event. Reliability is important in every event, because if you don't finish, you don't get any points. Lateral acceleration is important in skid pad. Longitudinal acceleration is important in acceleration, and both of those are important in autocross and endurance. So once you've decided which design requirements are the most important, you can design a car for that. And since reliability is so important, we've had our car done since February 1st, driving on February 1 for the first time, and that testing is why the car's been doing so well out there on the course.
As Formula SAE builds on 2 decades of accomplishments, the growing involvement of schools, as well as major automotive manufacturers and suppliers, will remain a fundamental element of its success. The event has already become a showcase for the finest young automotive engineering minds in the world, and provided an invaluable springboard for many of their careers. Formula SAE continues to be an example of the substantial benefits that can be obtained when the search for academic excellence receives the consistent support of industry leadership.